let's look at the area between two polar curves. Earlier in the semester, we looked at the area between two curves, y equal f of x and y equal g of x, and the area was basically the integral of the difference between the two. Well, a similar principle will work here. So let's write a theorem here. Suppose A is the area of a region bounded and here we have two polar curves. So the first one would be y equal f of theta. The other will be r equals, did I say y equal f of theta? I meant r equal f of theta. And the other is r equal g of theta. Okay? And then we're going to say we bound theta. Theta goes from theta 1 to theta 2. And the difference between the two, so the difference between the two thetas is bounded by 0 to 2 pi. Okay, so we can bound it like so. Actually, let me remove this, let me make it a proper inequality. Like so. Okay, there is one more condition. So this is all of these are supposition. The last supposition is we suppose that f of theta is greater than or equal in this matter g of theta. So one curve is on top of the other, and both are positive. Okay, so these are the conditions. And in this case, then we have the following. So let me put. Then the area is given. The area A is given by the following expression. A equals 1/2 the integral from theta 1 to theta 2. And remember how we did it before. We said it's one function minus the other, but if you recall, the area formula is 1/2 r squared, right? We have it right here, 1 r squared. And since r equals f of theta, here we can write on yesterday notes theta 1 from theta 2. Instead of 1/2 r, we can write f of theta squared d theta. Since for polar curve r equal f of theta. Okay, so we substitute r squared with either f squared or g squared. And since f is greater than or equal to g, then we'll go like that. So let's run through the first example here. Well, let's find the area lies inside the following. This is an interesting problem. Find the area of a region that lies inside the curve r equals 3 sine theta, and outside the curve r equals 1 plus sine theta. So what is r equal 3 sine theta, and what is r equals 1 plus sine theta? You should recognize the second one. And somebody said that, and that person said the cardioid, and that person is absolutely correct. So the second curve is the cardioid. What is the first one? You can look at it and think for a second. Let's go theta equals 0, and then theta equals pi over 4, pi over 2, and so on. Or let's cheat and look at the graphing calculator. Okay, now you can see it. So let's turn it on. Let's quit whatever I was doing. Okay, so I think I'm in the polar mode. Yes, I am. And so now we need to graph, and so let's do 3 sine theta and graph it. And it doesn't look good, but if I do zoom fade and then square it, perhaps it will work. So, still don't look pretty good, but let's do zoom square here. And somebody said circle, and that person is absolutely correct. So, if you think about it, what you see, when theta equals 0, r equals 0, so you're right here, okay, and you can trace, okay, when theta equals pi over 4, then you'll be, you'll be right here. When theta equals pi over 2, then r equals 3, so the diameter is 3. So this is a circle with diameter of 3. If we'll put the cardioid on top of it, well, we know how the cardioid look like, but let me put the cardioid on top of it. And I'm missing the bottom, so let me go ahead and zoom fade again, and hopefully this will show me the bottom. It does, but it looks distorted, so zoom square to the rescue. I think this will be a better picture. All right, so this is the shape. We know for the cardioid, this is where theta equals 0, and this is where theta equals 0 for the circle. This is where theta equals pi, and this is really where theta equals pi for the circle. Right, r equals 0 one more time. So really the circle we go twice, because this is 0 and this is pi over 2, and this is pi, and this is 3 pi over 2, and so on. So here's the picture, going back to the presenter. So we are back in business now. So let's sketch this thing. The circle with radius or with diameter equal to 3, and so 0 is here, pi over 2 is here for the circle. For the this is 3. For the cardioid, we remember we start right here with this is theta equals 0, the polar axis. So we go like that. On top is where theta equals pi over 2, the same angle. We come back. This is theta equals pi, and then we have this to segment between pi, 3 pi over 2, and 2 pi. So the area that we are interested in finding, whose area we, or the region whose area we need to find, is shaded like that. It's like a moon shape. And of course, we need to integrate from theta 1 to theta 2. Well, this is theta 1, which we need to find, whose value we need to find, and this is theta 2, whose value we need to find. And we need to find by looking at the intersection. Again, we can cheat and use our calculator, but this is no big deal. This is easy to find. We want R, let's say call it R1, and this is R2, the radius, the circle to equal the cardioid, and 3 sine theta to equal 1 plus sine theta. And if you solve it, then you have 2 sine theta equals 1, or sine theta equal 1/2. And there are two solutions in quad 1 and quad 2, where the sign is positive, and the solutions are pi over 6 and 5 pi over 6. So we have the boundaries of integration. Okay? The rest is we need to square both of them. I'll bring the paper in a second, in case you need to catch up copying. So the area is 1/2 the integral. We know that we need to go from pi over 6 to 5 pi over 6. And now we have the circle is greater than the cardioid. Remember, one of the conditions, the supposition is f is greater than g. Well, f is the circle 3 sine theta, and g is the cardioid 1 plus sine theta. Okay, and so we need to go f minus g. So f is the circle, so 3 sine theta squared minus 1 plus sine theta, we'll square it, and d theta. So this is what we are working on. Clear the parentheses. And let's see, this will be 9, well, let me write it out. 9 sine squared minus 1 minus 2 sine theta minus sine squared of theta d theta, like so. 1/2. We have 9 minus 1, so we have 8 sine squared of theta. And let's go minus 2 sine theta minus 1. What should I do next? Do tell. Specifically, since nobody answered yet, how do I handle the sine squared? Half angle, I agree. Or double angle in this case. We treated this half angle, we applied the double angle. Do you happen to remember? 1/2. Go ahead, Dave. It's 1/2. 1 minus cosine 2. Cosine squared is 1/2 1 plus cosine 2 theta. Sine squared is 1/2 1 minus cosine through theta. So this will be the substitution, the double angle substitution. Is Tommy said, some people call it half angle substitution. 1/2 of 8 is 4, and you have 4 times 1 minus cosine 2 theta, and then the rest hasn't changed. So all we need to put everything in order. So we have 4 minus 1, well, that will be 3, right? And then we have minus 4 cosine 2 theta minus 2 sine theta. And I'm ready to find the antiderivative. So 1/2 in front of everything, 3 theta, okay? Okay, the antiderivative of the cosine 2 theta is 1/2 sine 2 theta. So we have 4 in front, so it will be minus 2 sine 2 theta. Okay? Again, if you take the derivative, you get 4 cosine 2 theta. And here we have the antiderivative of the sine is the cosine, so simply plus 2 cosine theta. And all of this need to be evaluated from pi over 6 to 5 pi over 6. Okay, 1/2 in front of everything. 3 times 5 pi over 6 will be 5 pi over 2. Okay, 2 sine 2 theta. Sine of 2 pi over 6 is sine of pi over 3. Sine of pi over 3 is square root of 3 over 2. 2 times square root of 3 over 2 is simply square root of 3. So we have minus square root of 3. Cosine of 5 pi over 6. I'm sorry, did I say pi over 6? I meant sine of 2 pi over 6 is sine of, I'm sorry, let me reset myself, okay? I'm talking about this one. Sine of 2 theta equals sine of 5 pi over 3. 5 pi over 3 is in the third quadrant. So it's negative. So it's negative, negative, so that will be positive. Cosine of 5 pi over 6, that will be in the second quadrant. Cosine of 5 pi over 6 is square root of 3 over 2. Again, you have 2 square root of 3, but 5 pi over 6 will be negative because it's the second quadrant. So negative square root of 3 over 2 times 2, simply negative square root of 3. So we are happy because the two radicals cancel each other. Okay? And now we move on to evaluate for pi over 6. So we have 3 times pi over 6. Well, that will be simply pi over 2. And minus sine of 2 pi over 6, so sine of pi over 3. Again, that's square root of 3 over 2, but we have 2 of those, so this will be minus square root of 3. Cosine of pi over 6 is square root of 3 over 2 times 2 plus square root of 3. Once again, the radical cancel. So what's left really is 1/2, and we end up having 5 pi over 2 minus pi over 2 So we have 4 pi over 2, so we have 2 pi, 1/2 times 2 pi. I think the answer is pi.